Hello class, welcome to our lesson today dealing with Euchre probability again. Today we're going to be looking at some probabilities given that you know your hand and things like that. That's what's known as conditional probability. When you see conditional probability, remember that means probability of an event given, and that's typically used with this vertical line, given another event has already occurred. So for example, if I roll a six-sided die, I say what's the probability I rolled a 4 given I rolled an even. Well, since the given is rolled an even, I had to have rolled a 2, 4, or 6. And then there's one out of those three ways that you could have rolled a 4. So most of our conditional probability for Euchre is going to be based upon I know my hand, and then I try to figure something else out about an event. So when we deal with our Euchre unit, what you're going to want to make sure of is that you understand the notation that I'm going to be using. It's kind of hard to draw the cards themselves or write them out all the time, so I'll be using the following notation. Whatever the first letter is, that's like the number or the card. So like this is ace, this is jack, queen, 10, king. And then the dash, the other letter is the suit. So this is the ace of clubs, jack of hearts, queen of spades, etc. I'm going to use that notation for the rest of this unit and all of our videos and all of our lessons as we move through the Euchre unit. So just realize that that notation will be used by myself. If you have a different way of writing it, that's fine, but just realize that's how all of the slides will be looking. Okay, these are all find the probability. So your hand is the ace of clubs, jack of hearts, queen of spades, 10 of hearts, and king of diamonds. This says find the probability that the card flipped up. So this is the card that's flipped to see what the trump suit may be. If I haven't looked at my cards. So even though I told you this is my hand, this is like before I look at it. So the card flipped up being a jack is only one card. So the denominator is of the 24 cards in the Euchre deck, I choose one. The numerator is there's 4 jacks and you choose one. Technically the rest of it, 20 cards, choose 0, but I don't need the rest of them because I already picked the one card I need. This one being 1/6 or 0.167 if I round it to the nearest thousandth. But the key thing to this question is I'm only drawing one card instead of 5 cards. The next card is the exact same question, flip a jack, but this time I know my hand. So notice the denominator here is not 24, it's 19 because I know my 5 cards, which would be true in a game of Euchre at all times. Then it says the flipped up card is a jack. Well, there were 4 jacks in the deck, but I have one of them. So now it's only 3 out of 1 because I have one of the 4 jacks and there's 3 left over. So that makes it 3 out of 19, which is just under 16%. So notice here the probability went from just over 16% to just under because I know that I have one of the jacks. The next one is flip card is an ace. You haven't looked at your hand. So this actually is the same as the first slide with the jack because there's 4 aces, choose one, 24 cards, choose one for the denominator. I still get 1/6, which is the exact same probability. Every card number has the same likelihood to be chosen before you look at your hand and have conditional probability. Now it's saying that you know your hand. So conditionally, I want an ace given that I know my hand. So the aces here, I know these two. So there's only 2 aces left. So that would be 2, choose 1. So NCR, don't forget this idea is combination. Divided by 19, choose 1. And that would be 2 and 19 for the answer of 0.105. When we're looking at that situation, we're finding a probability based upon what was given to us. And so since we know our hand, we have to subtract those cards out of the group to figure out what's left over. The other version of questions is based upon what your partner would have. So 5 cards are dealt to each person. I know that my hand is the ace of clubs, the jack of hearts, the queen of spades, the 10 of hearts, and the king of diamonds. And saying what's the probability my partner has 3 kings and 2 nines. First off, let's talk about the denominator. Since I have my 5 cards, it's only going to be 19, choose 5. Now, in a game of Euchre, it's probably going to be 18 because we also know the flipped card. But for now, all I know is that I know my 5 cards and then what's left over. So the denominator will be 19, choose 5 for the rest of these questions that we're going to look at for today's lesson. The numerator should be 4, choose 3 because it's the 4 kings and I need 3 of them. But I have one of the 4 kings right here in my hand. So that means there's only 3 kings and I need all 3 of them. And of the 4 nines, I don't have any of them. I need 2 of them. That gives me 5 cards, so I don't need the leftovers. I technically could add the leftovers or multiply the leftovers, but it's going to be irrelevant. And so this would be my solution, 0.0005. Okay, the setup is this idea though. It's the same setup as the previous lesson that we did. It's just now it's out of 19s instead of out of 24. The next one says 3 queens, given that you know your hand, so the denominator, 19, choose 5. I have one of the 4 queens, so there's only 3 left. I choose 3. But then I still need 2 more cards in my hand, so I have to do the leftovers. 19 minus 3 would be 16, so there's 16 cards there. And then I need 2 more to make a 5-card hand for my Euchre hand. So it's 3 choose 3 times 16 choose 2, then divided by 19 choose 5. That answer then would be 0.0103, or just over 1%. The next one, 3 kings and 2 nines. Now this time I have a different hand. I've got 3 jacks here and 2 aces. So for the numerator, I don't have any of the kings, so that's 4 choose 3. I don't have any nines, so that's 4 choose 2. That's 5 cards total. But the denominator is still 19 choose 5 because I still know my hand. The condition of knowing my hand changed the probability slightly compared to what it would have been if it was 24 choose 5. And this is much more likely to be the case because in a game you typically know what your cards are, and then you use that to help distinguish other things. This one says 3 queens, so this is similar to what we had before. But notice here, instead of 3 choose 3, it's 4 choose 3, because I don't have any of the queens. So because of that, I've got 4 choose 3, and then the leftovers. So 19 minus 4 is 15. 5 minus 3 is 2. I have to multiply by 15 NCR2 or 15 choose 2 because I need 5 cards in the numerator. So I've got to multiply these pieces and multiply them together to find the answer. Then I divide by 19 choose 5 because it's always 19 choose 5 if I know my hand because I take 5 of the 24 cards out of the deck. This leaves me with an answer of just under 4%, so 3.61% or 0.0361 as a decimal. When you're dealing with Euchre probability, you want to make sure that you're dealing with the combination idea well. You want to make sure that you deal with the numerators, multiplying those answers together. But the numerators, they should add up together. Those numbers in the top and bottom of each NCR situation should add together to the total for the denominator. If you don't know your hand, there's 24 cards available. If you do know your hand, there's only 19 cards available. And then if you're only drawing a card, it should only choose 1 card. If you're looking at your partner's hand, then it needs to be out of 5 cards because your partner would have 5 of those 24 cards. Make sure you know how to multiply NCR on your calculator and how to find those answers. Have a good day, everyone.